Folks, hello and welcome to the Tuesday night lecture series by the Mid-Ulster Amateur Radio Club. We have a few new folks with us this evening. And Nathan, it's also good to see you as you're the one delivering the presentation. Nathan, you can unmute yourself, or you should be able to there anyway. And you can tell us a wee bit about yourself and what you're here for, what the crack is, and everything else. So, Nathan, whenever you're ready, over to you.
Thank you, Dave. So, my name's Nathan Prentice, MI0NPR, and I'm a member of Lochern Amateur Radio Club. I'm the RSGB youth representative for Region 8, and back in 2018, I was sent away to South Africa, where we learned a wee bit about Raspberry Pis, and even before that, I had a real interest in it through school, which is where I learned most of the tinkering side of things, and which is really what started me off programming and coding a bit for a few websites and web servers and stuff like that. So Dave kindly asked me along just to give you a wee talk about the Raspberry Pi, just a beginner's introduction, more or less, into the Raspberry Pi, and towards the end we'll be discussing how it can be used for amateur radio purposes. So I'll bring up my PowerPoint here, if that's all right. All right. So I'll be stopping a few times through the PowerPoint just to show a few demonstrations and stuff like that. But again, this is the Raspberry Pi PowerPoint, and it's an introduction into the Raspberry Pi, its use as an amateur radio and general hobbyist tinkering. So what is it? Why use it? A tinkerer's guide. Now, I'm by no means an expert in the subject. There's lots of people out there that are. I'm not one of them. I just enjoy using it. I enjoy tinkering. I enjoy the electronic side of it. There's a bit of programming as well, stuff like that. So I'm just going to show it from my perspective, and hopefully it'll get some people encouraged. Get the Raspberry Pis, if you already have one, get it out of the drawer, blow the dust off it, and start tinkering just. So what is a Raspberry Pi? So basically put, it is essentially a single board computer, and it's very low cost. The main benefit behind this is that it's credit card size. So straight away you can imagine that it can be used for a whole host of projects that, if portability is an issue, you can link it up to an external power supply or a phone charger and power it on the go. And because it's so small, it can be tucked away anywhere. So we'll be discussing a few uses in terms of radio and portable use later on. So why was it created? So for those that aren't maybe familiar with a Raspberry Pi, that's what it looks like over on the right-hand side. That's the latest model 4B. There's been a few revisions to get up to that point. We'll talk through them in a little minute. But the whole reason why it was created was originally it was aimed at school children. So I think it was MIT realized that there was going to be a shortage of computer programmers in the very near future. And one way of addressing that would be, let's make something that children can program on and that they can have a go, and if it doesn't work, it doesn't work. You just start over. So it was originally made by the Raspberry Pi Foundation, which is a UK-based charity. It's a registered charity to encourage young children to program and code. There's different levels of programming and code available within the Raspberry Pi. There's a beginner entry level, which is Scratch, which is, if anyone's ever used MIT's App Inventor, it's very similar. You drag blocks and you put these blocks into place, and it almost reads as plain English, so you don't have to learn how to code. But for those that want to develop more complex solutions to problems, there's other programming languages such as Python. So it's used in schools all over the globe to teach computer programming and computer science. That's how I got into caught the bug, would be one way of putting it. That's where I learned how to use the GPIO pins, how to wire up relays, how to create web services, all the fun stuff. Not only is the Raspberry Pi used in terms of schooling and teaching. It also has a very, very strong hobbyist community online. Very similar, if not better, than the Arduino community, which exists online. And there's a wide range of people sharing their project ideas. Source code as well is put up online. Most of it's free to use. You know, you just copy and paste the code, do a wee bit of editing, and away you go. So for the scale of production, just to get an idea of how popular a Raspberry Pi or the concept of Raspberry Pis are, there's been 30 million Raspberry Pis sold worldwide to date, and they're all made in the UK. It's a factory in South Wales. It's a Sony factory. And that they average about 15,000 Raspberry Pis per day across 10 different models. And they're distributed locally, and they're also distributed to larger outlets such as RS Components, Element 14, Farnell. The list goes on. MI0NPR, all these both online retailers and walk-in shop retailers as well. So the main distributors for the UK would be RS Components and Element 14. However, as with anything, you can always get them on eBay at quite a competitive price also. So this is the timeline for the Raspberry Pi. So it started off back in 2012 with the Raspberry Pi 1. Now at the time it was just called the Raspberry Pi because there was no other revisions at that point. But later, as they started adding more models into the mixture, they call it the Raspberry Pi 1, just to distinguish it between its later models. So it started off with the Model B, and then later on came the Model A. Now the Model A was meant to be a more low power, streamlined version of the Raspberry Pi. And then it went on to the B+. Now the big advantage of the B+, and I have one here to show you just after this slide. The big advantage of the B+ was that it had more USB outlets. So before you were limited to, if you had peripherals like a keyboard and a mouse, all you could plug in was a keyboard and a mouse, and you've already occupied the 2 USB slots. So if you wanted to add an internet connection, for example, and you had a USB dongle to do that, you'd either have to unplug your mouse or unplug your keyboard, or you could put in a USB hub. But they quickly realized that the problem with the USB hub was the fact that it drew too much power. The power consumption went quite high then. So that's why they brought in the B+. It added that extra functionality. Also, another notable improvement in the B+ was that they, instead of having a composite, there's always been a HDMI port for video, but there was also a composite. Now in the Model B, you can see it there in the yellow, just beside the blue jack, which is a 3.5mm audio jack. But in the B+, they combined them two together, and so you can get both your audio and your composite video from the one slot. So again, it reduced the board space needed, made it more compact. They rounded the corners. They made it the Model B. They made it better for mounting, because before the mounting holes were diagonal, but then whenever the B+ came along, they put them in the 4 corners more or less. So then there's the computing module as well that they've created. That's more for industrial applications. We'll not really be getting into that in tonight's talk because it's not really accessible. It's not practical for hobbyists. Then with the great success of the Model B+ and the Model B, obviously, they decided to make the Model A+, which turned out to be slimmer in design. They took away the 4 USB ports and instead just left it as one USB port. So it was aimed at sleeker projects. You could fit it in, you could tuck it in behind, say, a TV, and you could be running your media center on the unit. Something else actually worth noting is that the Model B, the original, only had, I believe, 26 GPIO pins. It's general input output pins, I think is what they're abbreviated to. But once you start connecting wires to it, you soon realize that 26 just isn't enough. So they upgraded them then to 40 pins now in all the models, more or less. So again, if we keep moving along on the timeline, the Raspberry Pi 3 came out in 2016. That was a big step up. It had more RAM. It had a dedicated GPU, which was faster than the previous models. The one downside with having a quicker and faster central processing unit was the fact that it got hot. So it was around this stage that the Raspberry Pis were beginning to become comparable to a desktop computer. Now, some people listening to this might have a computer with, I don't know, 16 gigabytes of RAM if you're doing some heavy work, but the Raspberry Pis now have up to 8 gigabytes of RAM as well. So it's faster than the laptop I have at home. So it is, believe it or not. But then in 2018, they released the B Plus again. This time they were focusing on heat transfer. So they added a metal heatsink more or less over the CPU as well. And again, they rolled out this then to their Model A Plus and their computing module as well. But in 2019, their more recent Raspberry Pi, they released the Raspberry Pi 4 and it had a whole host of upgrades. But before I get too carried away, I just want to show the Raspberry Pis that I own. So you can still see me here. This is a Raspberry Pi. This was the B. This is the Model B. You can tell that because it only has 2 USB ports. They all have Ethernet. Now, at the very start, the Ethernet was slow, but now they've moved that to gigabit Ethernet. In the very start, you had your composite video and your audio jack. So later on, they merged them two together. Down here is your GPIO pins. So they made them extend the whole way across in the later models. One big annoyance that bugged me a lot about the Raspberry Pi, the first ones, was that it used a full-size SD card, and as you can tell, that can't go anywhere. That's where that sits. And if you're trying to put it away in a nice box or you've bought a case for it, the end still sticks out. In fact, here's a case I happen to own. So that's just the bottom half of the case, but you can see there that the back end of it sticks out. So it's not ideal because you could hit it, you can accidentally pull it out. There's nothing actually to stop this from being pulled out. So if you were running a program and something accidentally bumped it and it pulled out, your Raspberry Pi would stop working. But then my next purchase was a Model B Plus, which again has the 2 USB ports. I got a nice case for it that still leaves the GPIO pins accessible, because at that stage, this is the one I used whenever I was at school. So I was doing a lot of tinkering about, and this one here, actually, I don't know if you'll be able to see it or not, but it has the GPIO pins numbered. So that's very useful whenever you're looking at a schematic that someone else maybe has drawn up on how to wire a temperature sensor, for example, and they're referring to these pins. It's very, very useful to have the pins on the case, especially whenever you're learning. It just makes it a whole lot easier. And again, this one, they shrunk it down to a micro SD card. So, and then more recently, whenever I was in South Africa, I got the Model 3. Now it's in a case, but the one downside I would have about this is that the case doesn't have a fan, and if you leave the top on, it gets quite hot, so you need to keep a little eye on it. So go back into the PowerPoint. Well, let's see. All right. Hopefully that's us. All right, so hopefully that's back up on your screen. So as I like to call them, the flavors of pie. Now, as someone said before we started, these don't taste as good as the real pies. But again, just as I was talking through, these are the different models that came out and the specs. So you can see at the very start, the processor was 700 megahertz, which I think someone compared it to a Pentium processor, which used to be in the older style laptops, and it had 0.5 gigabyte of RAM. So again, not excessive amounts of RAM anyway. At the start, they were quite slow. And then the next jump up, other than the Bs and the B pluses, would have been the Pi 2, which upgraded the processor from a dual core to a quad core, and they extended out the GPIO pins. Then the Pi 3 again, they upgraded the processor again, sticking with a quad core, this time 1.2 gigahertz. The architecture of that processor is 64-bit. However, the funny thing is that the operating system, which we'll get into later, it's a 32-bit operating system. So you've all that extra functionality there, but it's not really being utilized at the minute. And this is the latest Raspberry Pi 4. So we can see here that this is taken directly from the Raspberry Pi's website. One upgrade that I actually forgot to mention was that they changed the power supply socket, I suppose, from micro USB to USB-C. That's because the latest Raspberry Pi 4 is a bit more power hungry, and the USB-C just allows more delivery of that power. It seems to be the way that more modern phones are going. So I suppose at the time of release of Raspberry Pi, the idea was to go with micro USB, because that's what the majority of Android users that had phones were charging the phone with. But now that different companies like Samsung and Huawei are moving to USB-C, I think the Raspberry Pi Foundation just decided to do the same. Also worth noting in the latest Raspberry Pi 4 is the fact that you can choose the amount of RAM. Obviously, whenever you're choosing how much RAM you want, the price does increase with how much RAM you want. But I think the last time I checked, a Raspberry Pi does not cost more than £50. Whenever I started out, I managed to get mine for, I think it was £25. And considering that's quite an old version, you could get started with Raspberry 3, for example, which doesn't just have all the fancy bits of Raspberry Pi 4, but it's plenty good enough to get the job done. And on the latest Raspberry Pi 4, instead of having one HDMI port, they have now two micro HDMI ports, which can support 4K at 60 frames per second. And there's two USB 2.0s and two USB 3.0s, so there's no reason why you couldn't link up an SSD to it and copy files across that way if you're operating some large server from it, or a web server, for example, where there is a decent amount of files. You can plug them into the USB 3 and away you go. So I've discussed it a little bit, but this is the bread and butter. This is the differences between the very first Raspberry Pi that came out and the newest Raspberry Pi. So the original one did not have built-in Wi-Fi or built-in Bluetooth, whereas the new Raspberry Pi 4 does have both of them built in as standard. More notably, it has the 2.4 and the 5 gigahertz wireless Wi-Fi connectors. So if you have Wi-Fi at home that can support that, it can cope with the speeds just fine.
Nathan, can I ask you, see when you're presenting, can you mute your video because your audio is, we're getting you a fading on your audio?
No problem.
If you mute your video, it might help the audio.
Yeah, no bother.
Thank you.
Thank you. Hopefully that's a little bit better. All right. So before I was talking about it was the more power-hungry Raspberry Pis as such, whereas these are the more lightweight. These are for your portable applications, for example. So your A Plus is the same as the original Pi, just a smaller form factor. Like I said, they took away a USB port. It can consume from anywhere from about 0.5 watt to 1 watt, just depending on what's connected to it. And the Raspberry Pi Zero, there's 2 different versions of the Raspberry Pi Zero. One of them's a Zero and one of them's a W. And the difference with the W stands for wireless. So as you can see in red there, that's the options that apply to a W, and the other options just apply for a standard Pi Zero. Originally, these Raspberry Pis, now they might only be 65 millimeters wide. They're not big units at all. They were actually given out for free on the cover of MagPi, which is the official Raspberry Pi magazine. You can buy a standard one for about £5, and the wireless version sells for about 10 on average. So how to use a Pi? Very, very simple. You add a keyboard, you add a mouse, you add a monitor, you add your SD card, which has to be loaded and burned, it's called, with an operating system. And if you want, you can have an internet connection. Again, it's not essential, but if you want to run updates, every once in a while, just to keep the operating system up to date, because they regularly post improvements for the OS. And then just add a power supply and off you go. What I failed to mention here was you don't even need to have a keyboard, a mouse, or a monitor. You can log into these through SSH, for example, which once you have the Raspberry Pi configured on the network, you can use another computer on the same network and jump into it, and you can use the terminal. You can also use VNC, which brings up the full, more or less, you're staring at the Raspberry Pi's desktop environment, much the same as Windows. And you can do that as well without a keyboard, a mouse, and a monitor. So one of the main benefits of that is you can control your Raspberry Pi from anywhere in the world, essentially, if you have it configured right. So these are some of the peripherals that are available, official peripherals. So there's the camera module, which I have one here. I'll demonstrate it in a second. So hopefully you can see this. So this is the camera module. Now this is one of the very first revisions, and it has a little ribbon cable, and the ribbon cable just plugs straight into the board, and it can only actually go in one way, which makes it sort of idiot-proof, if you want to call it that. But there is different versions now available of the camera module. So I'll get into that now. So there was the infrared camera, version 2. So it was mainly used for if you wanted to take night shots or time lapses outside of hedgehogs running about in the garden, or see if there's any bird activity at night, stuff like that. There's the PoE hat, which stands for Power over Ethernet. That's one of the latest boards that can be bought for the Raspberry Pi. It essentially means that you can supply power through the Ethernet cord now, so you don't even need to have a dedicated power supply for the Raspberry Pi. So that's fantastic if you did want to, say, have the Raspberry Pi running up in your attic for some reason and there was no power sockets available. You can just run it up with the Ethernet and power it that way. Another official peripheral is the Sense hat. We'll get into hats more as we go through the PowerPoint, but a hat is essentially a pre-made board that drops on top of the Raspberry Pi, and it usually has some sort of gadgetry, which is very useful. So in the case of the Sense hat, it has a temperature sensor, humidity sensor. It has a LED matrix as well, so if you wanted to display text, you could do that as well. And down here on the bottom, there's one of the more recent camera improvements, I suppose you could say, is the high quality camera. So before the original cameras, the V2s, they're quite cheap. You're talking maybe 15 to 20 pounds, whereas the high quality cameras are now actually in and around the £50 mark, which is quite expensive whenever you consider the fact that you can buy a Raspberry Pi for that, well under that. But what makes this camera so good is you can use your own lenses. So if you wanted to take 4K photos, that's now possible. And you can put in your own macro lens or wide lens to suit whatever application. And there's a Raspberry Pi touch display. It's a 7-inch, I think it's a FT touchscreen display, which is meant to be plug and play. And the very last one is an official Raspberry Pi TV hat. So you can plug in your connector to your aerial and essentially decode television from your Raspberry Pi. So keep moving. PowerPoint's thinking about it here. So it is. Hopefully. There we go. Okay. So I touched on the SD card. Now the SD card is used to load on the operating system. So what you can do is you can load your whole operating system onto one SD card. If something happens and you mess it up, all you have to do is unplug it, reflash it again, plug it back into the Pi. That's what makes them so good for education, because touch wood, you can't really defunk a Pi. It'll not blow up, it'll not pop fuses normally unless there's something wrong with your power supply. But there's nothing really that you can do in code or in the command line that will totally mess up your Raspberry Pi. So the latest operating system is Raspberry Pi OS. The name was originally called Raspbian, and it was based on a Linux distribution called Debian, which is one of the most popular Linux distributions out there. It's all open source. The community contributes towards putting in improvements and stuff like that. So the OS downloads from an image file. So you can go onto the Raspberry Pi's website and download their pre-configured image. And all you have to do then is plug in your SD card, and you have to use a special bit of software. It's nothing too tasking at all. You plug in your SD card and you just flash the SD card. On the right-hand side of the PowerPoint, there's two different operating systems. So the Raspberry Pi OS, which would be the most basic, I suppose, and most streamlined official Raspberry Pi operating system, whereas Noobs is for new people and people who don't want to spend time at the command line downloading new software packages. So Noobs comes pre-installed with all the software that you're likely to require. So for anyone that maybe doesn't know the functions of the OS on this, as opposed to an Arduino, the Raspberry Pi has a graphical user interface, or GUI as some people like to call it. So it'll boot up exactly the same as a Windows PC, as a Mac, for example. And like I said, if anything goes wrong, you can just swap out the OS, or if you wanted to change it, if you wanted to try something different, try a different operating system, give something a go, you just plug it out and you swap it and plug it back in. And the fact that it uses an SD card means that there's no bulky hard drives needed. You don't need to worry about magnets getting too close to it, for example. So it's great. It keeps it all compact. And the SD card is reliable now. In the past, it wasn't just as reliable because you could pull out the card. There was nothing holding the larger SD card in. But now there's like a detent, so you can't physically pull it out. You have to push it in and pull it out. And like I said, the same SD card can be burned over and over. However, it may begin to degrade once you've burned it maybe 50 to 100 times, but that shouldn't really be a problem for anybody. And like I said, Noobs comes pre-installed with all these packages. It's real VNC, so essentially that's for headless connection. So you can use your Raspberry Pi on the go. You can leave it at the house. You could be checking on your Raspberry Pi at work, for example. If you had a surveillance system, you could look that up from the phone using the VNC software. And LibreOffice, it's the Linux equivalent, I guess, of Microsoft Office. So you have your equivalent of Microsoft Word, Microsoft Excel, PowerPoint, Publisher, Access. They're all free to use, and they're all compatible with the Windows equivalents. So you can work on a Raspberry Pi at home, say, and if you had to go into the office or someone wanted it through in a Word document format, you can just save it as that format and it'll read through perfectly. Some of the other notable mentions are the Chrome. It's actually a Chromium web browser. It's a more lightweight version of Google Chrome. You have Archiver for unzipping files, which can happen if you're downloading pieces of software. Calculator, File Manager, Image Viewer, PDF Viewer, SD card copier. So if you wanted to copy the contents of your SD card, you can do that quite easily. Task Manager Terminal, which is very useful for configuring some boot up files, for example, and you have a text editor. So more or less straight out of the gate of setting up your Raspberry Pi, you have all the software that you need to run it and run it effectively. That being said, there are lots of different other operating systems. Ubuntu is probably the most popular Linux distribution. So you can download an equivalent of that for the Raspberry Pi. So that's your three flavors of it there at the top. And OSMC, we'll touch on that in a little minute. And the other ones are just, they're crowd contributed operating systems. So something that somebody wants to try out, like for example PiNet, where they connect up all the different Raspberry Pis to perform one task. You can download that operating system and contribute to that as well. So some people might be thinking, okay, I have an Arduino, why do I want a Raspberry Pi, or maybe vice versa. So personally, I have both an Arduino and a Raspberry Pi. Each of them has their own benefits, drawbacks, a bit like anything. There are reasons for using both. Probably the main reason for using a Raspberry Pi would be the fact that you have a full boot up, you have a full GUI, you have your full interface. You can use it just like a normal desktop PC, whereas the Arduino, you obviously can't do that. It boots, or you have to connect it to a power source, and you can only program it from an external PC. So it's not a self-contained unit as such. They can both take inputs and outputs, digital or analog. If you're doing large amounts of inputs and outputs, Arduino might be the way to go, because as I said, the Raspberry Pi is limited to 40 GPIO pins, whereas an Arduino Leonardo, for example, or an Arduino Mega has more than that. They have more pins that you can use essentially. So these are hats versus shields. So again, this is a Raspberry Pi versus Arduino comparison that I'm doing here. So hats are for Raspberry Pis, whereas shields are for Arduinos. You can buy hats and shields to do essentially the same things. There are some RF modules for, I think it's the PMR frequency band, that you can essentially make a walkie-talkie from two different Raspberry Pi units or two different Arduinos. And there's lots of different hats out there. People are making their own and selling them on eBay, for example. eBay probably is the best place to look for all this stuff too, by the way. If anyone is interested in getting started, eBay is probably the place to go. So at this point, you're probably asking, okay, Nathan, we know what it is, we know the configuration of it, but why would I want to buy one? They are easily available online. I think that's the whole idea of a Raspberry Pi, is that it's so accessible. The price point leaves it so that almost everybody can buy a model. Now, it doesn't have to be the latest model, for example, but they're not ridiculously priced, which is a bit strange, essentially, if you're considering the amateur radio community, because a lot of things sometimes seem overpriced for what you're getting. A Raspberry Pi also has an intuitive operating system, so it's very easy to use, whereas an Arduino, it doesn't just have that user-friendliness about it, and you have to have a separate PC to program it. There are endless tinkering possibilities with a Raspberry Pi. I've only scratched the surface of what a Raspberry Pi can be used for. They're low cost and high reliability. They're ideal for automating tasks, especially if you connect them to the internet, and I'll touch on that in a quick second. And they have a rich community online. So more often than not, the times that I was stuck, I resorted to online, a quick Google search, and there's plenty of support online there to get you up and going. So, okay, so I think I might buy one, but what can you do with it? Again, some people that may have heard this talk before, people ask me sometimes whenever I was at school, for example, well, what can a Raspberry Pi do? It's only a small thing. Well, I tend to direct the question back and say, well, what would you like it to do? There's that many things that you can do with a Raspberry Pi. So here's some hobbyist projects, not specifically radio related. We'll get into them a little bit later. So these are some small projects that are easy to do, quick to set up, good fun. So a media center. Now I think everybody has heard of Netflix and all these streaming services, Amazon Prime, but the Raspberry Pi can be used as its own media center. So again, you flash the operating system on the SD card, the OSMC operating system, and it generates this engine that you can use to watch movies, TV shows, videos, so on and so forth, music, and you can listen to online radio. It's completely free to use. If you feel like it's not for you, just try it for a little while and then reflash the SD card, no harm done. So it can also be used as a desktop computer, as I mentioned, especially with the latest versions. So you can do all your Excel calculations, for example, from the Raspberry Pi. It's now powerful enough to handle excessive, streaming, for example. It can handle, going on YouTube for hours on end, provided that you have a fan. It can deal with text editing, no problem whatsoever. And although it mightn't just be as compatible as using a Windows or a Mac, there are programs there that can get over that hurdle. And like I said, it now has similar performance, especially with the 4B that came out, which has 8 gigabytes of RAM. The performance now is quite comparable to a normal desktop or PC or a laptop. Gaming, now this by no means is it hardcore gaming or anything like that. This was one of the ways that they originally got school children involved in it. They released Raspberry Pi edition, Minecraft, and the whole idea of it was that you could edit your world and add in different bits of code to see what it does, and that got a lot of people into Python, for example, one of the programming languages. Something that I've tried extensively, and for this, I just through the archives, I kept screenshots of things that I did, and this was just an example of a very, very basic website that I hosted on the Raspberry Pi. So just plugged it into the Ethernet, downloaded a piece of software called Apache, and it ran Apache no problem 24/7. That being said, there wasn't much traffic on the site, but you can port forward your Wi-Fi router and make it visible to the outside world. So this is something, if maybe you had instructions on how to do something radio related, or maybe another hobby that you're interested in, you can get your own domain name for free online. There's different websites available to register a free domain, and you can add to your website, no problem. You can set up a WordPress site as well, and you can. The limitations are endless. Surveillance system. So that's like I touched on. You can plug in the camera module, like there in the bottom right corner, and you can watch your neighbors. You can watch your garden. You could have it in your shed, in your attic. if you really wanted to get fancy, you could hook it up to a few motors and, you know, set up a fancy time-lapse system where the camera moves over a period of time. The normal camera can be used for taking daytime photos. Whenever it turns to night, unless you have a light there, you'll probably need the infrared version of the camera. So it's great for time lapses, and it can be linked into the website. And the Raspberry Pi Explained book touches on how you can use, or it goes into a lot of depth actually, on how you can set up a dedicated surveillance system on a Raspberry Pi. The possibilities are endless. So these are just a few of the sensors that you can buy online. They work for both Arduino and Raspberry Pi. So if you happen to have both, happy days, you can use them for both. Proximity sensors, temperature sensors, motion, the list goes on and on and on. And you can hook these up to things like motors, actuators, light switches, fans, sirens, buzzers. Really, the tinkering, you know, can go on forever just based on these. A good one would probably be maybe a night light. It would be a bit overkill maybe to use a Raspberry Pi for it, but it's more than possible that once it senses darkness, you know, maybe turn on the living room light or turn off bedroom lights after a certain time. You know, there's possibilities there. It just takes a bit of brain power. So those are some projects that, you know, are quick and easy to get into. These are some of the projects that I've tried. General tinkering, nothing too extravagant. One of the projects that we done at school, now we're talking at this stage, it was 2016, whenever I first started getting into the Raspberry Pi, and this was well before Hive came out. Hive, as some of you may know, is you see it advertised on the TV that you can control your home from your phone, is the way the slogan goes. So at school we were experimenting with things like that, where we set up a web server, and on the homepage it had different buttons. So for example, it might have had a button for turn on ceiling fan, turn on heating, turn on hot water, turn on TVs, for example. What else? Maybe turn on the oven, you know, all these possibilities. But we set it up with simple buttons. Whenever them buttons were pressed, it would trigger the Raspberry Pi to send an output to a relay. And from the relay, then you could power your larger appliances, like lights, for example. And it was only after we'd completed this and we'd done the proof of concept, and, you know, someone from the school went outside and they had the website on their phone that they could access through mobile data. So essentially, if you were to implement it in your own house, what you could do is, if you're on your way home from work or on your way home from a walk, for example, and okay, I want the heating on, or I want the TV to be on for some reason whenever I walk in through the door, you just press a button and that can happen from anywhere. Something that we didn't touch into, but something that would be very possible, would be to set up a camera link on that same web page so that you could check on the house. For example, if you're away on holidays, it would be fantastic if you could keep the house warm when you're away on holidays. Make sure that there's no intruders, make sure windows are shut and things like that. So another thing that we touched on in school was the ASTRO Pi event. It's still running. It's a great way probably to, if you're interested in getting young people into amateur radio, into Raspberry Pis, you know, just exploring that avenue. The ASTRO Pi event is, simply put, you write a bit of code on the Sense hat. They call it the ASTRO Pi hat for this challenge. And you write a bit of code, and if you win, it goes up to space, and they run it for, I think it's 3 orbits, which is about 4 hours maybe. There's different levels of that. There's ones aged from 14 to 19. There's ones aged up to 13, and they run for 30 seconds at a time. The whole idea is you're collecting data, and they'll happily run it on the International Space Station. Whenever they're finished running it, then you download all your data from it, and you can analyze it like a real scientist. That's the motto of the ASTRO Pi as such. So Heat sensors, that's another one that we touched on too. The heat sensors for these are absolutely everywhere. They're cheap on eBay. You're chatting about £2 for a decent heat sensor. It's 3 wires, hook it up. It'll read constantly what the temperature is. So if it gets too warm, you can link that over to a relay, like what we done, and it'll switch off, or it might open a window, for example. You can hook it up to an actuator, or you can just have it as an LCD display and just output the temperature maybe of your room or your shack, for example, or the temperature outside if you wanted to go down that route. I've made a note here that it's especially useful for greenhouse. I don't know if anyone has any green fingers or garden orientated, but this would be ideal if you hooked it up to some sort of RAM, small actuator. You could have it open up windows in a greenhouse, for example. So other ones that we touched on at school were the parent detector, as it was called. I've included a link there, and I can send this through to Dave or whoever, and they can share these links with everyone at the very end. But essentially, the parent detector is a motion detector sensor, and whenever it detects movement, the whole idea was that it takes a few photos, it'll take a video. You can hook it up to sound a siren. The whole idea was to get children involved, and it gives them something fun to work on. So other projects are available on the Raspberry Pi Foundation's website. There's absolutely tons. I couldn't fit them all in this, but the link's there. If anyone wants to maybe take a look at that, there's different projects now. They go from beginner right up the way to advanced. So there might be something in there for you if you're totally new, or I know some people already have Raspberry Pis and they're looking at that next challenge. Time lapse, that's something that we done as well at school, and I've done it here at home as well. The only thing I would say is at the time of us doing time lapses, we done the quick and dirty method of just take a photo every 2 seconds and put it into this folder, and then later on we'll deal with it and put it together in a video format. Whereas now there's better ways that it can automatically do that for you, and you don't have to worry about editing or anything like that. This is another project that I've tried now. This one is radio related. It's still work in progress, but I was using a Raspberry Pi. I should explain that where my shack set up here in my bedroom, I have a TV monitor, and connected to that I have which would be my Raspberry Pi 3, and I was programming with it, and essentially what I wanted to do was set up a Yagi indoors and link it then to my radio. But obviously with it being directional, I wanted to turn it, so I set up a stepper motor for the north, south, east, west rotation, for example, and then I set up a servo motor which can only really rotate 180 degrees, and that's for the polarization of the Yagi. The way that it had worked it was that it had a keypad for manual entry, so you just typed in the bearing. If I get a chance in the future, I'd love to hook that up to QRZ and pull that information automatically whenever you're in a logbook on the Raspberry Pi, for example. My plan is to use the Raspberry Pi as a dedicated shack computer, because they're now powerful enough to do that. Something that I'd thought about doing before this was getting a windshield wiper motor of a car from a scrap yard, for example, and you can hook that up through a set of relays, maybe a 12-volt battery. And if you had a more substantial antenna 2-turn, it could handle that the very best, whereas this is a light-duty antenna rotator. Another thing radio related, this is partly what got me into amateur radio, was that I was tinkering about with the Raspberry Pi and came across a video from Make Magazine where they set up a radio station. I'm not encouraging anybody to do this, but as a proof of concept, you can use your Raspberry Pi to run its CPU clock at a desired frequency, and it'll have a general broadcast range of about 20 meters or so, a radius of about 20 meters. So nothing too substantial, but it's good fun. And you can load music onto it. You can load voice recordings onto it. This is one of the things that first actually got me started in amateur radio. And there's a full article on it in Make Magazine. Do it at your own risk. You know, it goes without saying, keep within your license conditions and all that. But again, it's another project, and it is quite fun to try. I know of some people online that have this set up in their car. However, there's better and cheaper ways to, if you wanted to do that in your car. But this is a bit of a homebrew option if you really wanted to do that. Really, the ideas are endless. These are just a snippet of what is possible. Whenever I was doing this PowerPoint, things were popping into my head. You know, if you didn't have a shack clock, you could soon make one of them. There's a photo of a real-time clock module that you can pop on the top of the Raspberry Pi. It'll always keep the time. If you wanted to display your grid square, for example, you can hook up a GPS, a USB GPS unit, and it can automatically update your grid square. You could take it out portable with you, just connect it to a power bank, maybe an alarm to repeat the call signs during an extended contact. You know, since I touched on there that the Raspberry Pi can come installed with the equivalent of Microsoft, you can set up your own login software as well using one of the database equivalent to Access, essentially. So if you didn't like the format of maybe the login softwares that are currently out there, you could make your own and set up reports for that to print out labels and addresses and stuff like that. But anything is possible. So, okay, that's all right. You're probably thinking by this stage, all right, okay, but what about amateur radio? So these are some of the uses. Now, I'll reiterate the point, I'm by no means an expert in these. I've been going off research from different people on what works, what doesn't work, and these are some of the tried and tested uses for a Raspberry Pi in amateur radio. So this one, actually, I should say I've tried this myself. The code is up online in that GitHub link there at the very bottom. The original article featured a MFJ 550 MORSE key. Again, it's a 2 wires. You can hook it up to whatever. You can hook it up to a paddle actually as well. There's an option for that. Essentially what the program does is it runs in the command line. So you could be training if you're waiting for a contact to come through or text to come through. You could be practicing your Morse code. Connect your Morse key to the Raspberry Pi, tap away, and the program will decode your Morse as you send it. So it can read what you're sending. It does it quite reliably, actually, believe it or not. You can adjust your words per minute, and you can listen back. In some cases, you can listen back to what you were sending, and it's a cheap alternative to other decoders and trainers. However, at the minute, it does lack the functionality of splurting out a string of text, and then you repeat it back to the system. But if someone wanted to have a go programming that, it would be challenging, but I think it would be very worthwhile, and there'd be a lot of people out there that would be looking for something very similar. Data modes as well. I know that Mike Richards done a talk about the Raspberry, I think a week or so back, and he touched on data modes. I would point you in his direction if data modes is what you wanted to use it for. I point you in the direction of his book. It's excellent. Tells you exactly how to configure everything, all the pieces of software that you'll need. And even there at the bottom, I've made a note that he actually sells pre-configured SD cards, so you don't have to faff about building these things up from source, which can be a little daunting if it's your first time using a Raspberry Pi. And if the great thing is, though, if something did happen to go wrong, just take the card out, put it back in, and go again. Just Software-defined radio. It uses one of them cheap, I don't have mine on me at the minute, but it uses one of them cheap RTL SDR dongles, which can be got off eBay for a few pounds. And it can decode a frequency range anywhere from 25 megs to 1.8 gigs. That can be extended as well. Just plug in the adapter for your antenna, screw it in, and we go. Something that I would be interested in would be seeing if this can go headless. So like I said earlier, just connect your Ethernet cable, which supplies all the power, all of the data lines too. So if you had a hilltop location and you had, a big power bank that might keep you going for a week, for example, you could set this up. And if at home you weren't getting that great coverage or reception, you can use it as your reference, and you can use it to receive signals, and in the hope that your transmit will get out to the right people. And again, pre-installed SD cards can be bought again from Mike on his website. Whisper Station, this is something that I bought the kit for, but it just hasn't got the full length of being totally finished. Weak signal propagation reporter for anyone who's maybe unfamiliar with Whisper. It sends low power signals, which is ideal for a Raspberry Pi. You don't need anything power hungry in this case. And the only thing I would say is the RF produced by a Raspberry Pi is noisy, and it does have harmonics simply because it's just turning on and off the transistors in the CPU to the right frequency. So you will need filters. A band pass filter probably would be the best solution there. And a shield or a hat is required. It's not required, but it has a nice BNC connector or an SMA that you can hook up your favorite antenna to, essentially. And then you can log all of your reports that are coming in from stations worldwide. Satellite tracking, this is something that I used the Raspberry Pi for whenever the ISS was doing an event where they were sending through SSTV. I used this just to see when the next pass would be. It's free to use. You can track all of your amateur radio satellites if that's something that you're into. You can print out a list of all the next passes that are over your location, all information like the uplinks, the downlinks, the CT/CSS tones that are needed for amateur satellites are all there and ready to use. So it is a great tool, and that one is very simple to download, both on a Raspberry Pi or a PC as well. So PIVFO, now I bought the little PCB that you can see there. Although this is again another one of these projects that didn't just make it into the final stages, but it is a BNC as well. You can use your Raspberry Pi as a VFO. So I think if you were going to be testing equipment, it can output a very weak signal that you could detect with a dummy load, for example, just to make sure that maybe a homebrew kit is on the right frequency that you're wanting it to be on. And the company that makes them is Language Spy. I believe they were at the Lochern rally a number of years back. That's where I bought the board, but they do a website as well if anybody's interested. CQR logger, that's another, it's a piece of logging software as the name suggests, and this makes the Raspberry Pi ideal for a shack computer because it has all the integration that you might need with QRZ, logbook of the world. You can view the cluster on it as well. It is a comprehensive package and it is quite good. You can print out labels from it if you're going to be QSL as well. And this is something, whenever I originally done this talk in Lochern and West Tyrone Amateur Radio Club, I'd mentioned that at the time you could buy a weather centre for £120. Now this is one from Maplin at the time. For those people that maybe like to listen to the IRTS transmission, you can give your weather details, for example, to the net controller. This might be something that they would be interested in. Whereas if you priced out all the different components for a Raspberry Pi, you can do it for £40 now. Obviously, if you value your time, there's the labour element of that as well. But if someone wants to get going on cheap, this is one of the ways to do that. Notable mentions as well, you can use the Raspberry Pi for APRS, something that's a whole other world to me, and I haven't delved into that just yet. You can use it for remote station control. Like I said, you can connect your antenna on a hill, maybe a mile or two away if it has internet connection, for example. You can use it to control your rig, your shack rig. You could try something like I did, where you can rig up sort of a homebrew antenna rotator. You could make it heavy duty by adding a windshield wiper motor, which would allow the full swivel in both directions. And another thing that I know there's a lot of people on YouTube that are very into this, would be using a Raspberry Pi for a de-expedition or a Go kit, or they put it in what they call their Go bags and take it out in the field with them, portable. Again, you could be running all of your login software on the Raspberry Pi and wirelessly connect to your mobile phone. That's another option as well. You can set up the Raspberry Pi as a Wi-Fi hotspot, so it can generate its own Wi-Fi, and you can connect your phone to that and exchange data that way. And something that I'm going to be experimenting a little bit with more in the future is time-lapse control on a 3D printer. So I recently ordered a 3D printer, so I'm eager to get a Raspberry Pi set up alongside to do some nice time lapses of that. Just see how it goes. So my recommendations, so we're coming towards the end of the talk, but my recommendations for anybody who wants to maybe get started or already has a Raspberry Pi but they're not sure what to do, my recommendation would be to buy a kit which is similar to the one on the right hand side of the screen. Although I bought this, it had an Arduino in it, but all the components are interchangeable. It has keypads, temperature sensors, humidity sensors, servos, stepper motors, analog joysticks, the buzzers, the list goes on, and it can be bought at a really, really cheap price of about £20. If you were to source all this individually, it would come, the total would be a lot more. And it comes in a nice case too, so you can keep your Raspberry Pi self-contained within the box whenever you're not using it. I would firstly recommend to buy a Raspberry Pi, probably Model 3 upwards, just because it has that extra oomph in terms of processing power, and it can run more or less all the amateur radio applications that you could be using it for example, digital modes. If you can splurge a little bit and go for the Pi B, the 4B, I should say, by all means, I don't think you'll regret it for the price point. And experimentation is at the heart of the hobby. It's in our license, experimentation, amateur radio, they're linked hand in hand. So the Raspberry Pi is great for that. And if anybody would like help getting set up for the first time, drop me an email. I can write up a few instructions. If needs be, I can flash the SD cards myself and send them out to you. It's no big deal. Again, not an expert. For the experts, I would go to the following people. There's a few people on YouTube which are worth noting. Their call signs are both there. They do a lot of portable work, and they're absolute geniuses whenever it comes to digital modes with the Raspberry Pi. And for further reading, I really would recommend Mike's book that was recently published. So that's all I have to say. Thank you for listening. And if there are any questions, I will be happy to answer them as best I can. Just don't be too harsh. I'm not an expert, but I will try my best. So at this stage, I'll hand back to Dave. If that's all right.
Nathan, thank you very much. I just have one question. Should we be worried about the Raspberry Pi? Because I have seen the Terminator movies before, and it almost sounds like there's nothing that these Raspberry Pis can't do.
That's it. The rise of the machines is coming, especially if the whole of Mid-Ulster Amateur Radio Club decides to take up Raspberry Pis now. It wouldn't be too good.
Folks, you can unmute yourselves there if you want to ask any questions at all.
Nathan, can I ask the question?
Yes, Philip.
I assume you're not using a Raspberry Pi for this presentation.
No, I'm using a work laptop actually.
You're using a Microsoft machine, aren't you?
Yeah, that's 100%.
You didn't see my message and didn't catch what I was saying earlier on, but with USB, or not USB, what do you call it, fading there on your audio.
Right.
I was trying to tell you to mute your video. Is your work laptop linked by Wi-Fi?
Yeah, it is, yeah.
That explains it too. Yeah, it's just the audio was going up and down.
Was it?
But the whole presentation was excellent. Wee bit more on it than what I've seen before, which is very, very good.
That's grand.
So it'd be great if you could send Dave them links too, so we can.
Yeah, no problem. I can forward on this PowerPoint and of use. You know, you can work away.
Good man. When you say work, what are you working at the minute?
Big rock crushers at the minute. So quality inspector. So it's not so much electronics, but it's more in the engineering side of things now. So
good man. Locally to home.
It's about half an hour away, just outside Ballygolly.
Good job. Good man.
Yeah.
Nathan, the most simplest project to do, first of all, what would you recommend? The most simplest thing? I have a Raspberry Pi, and it's the Raspberry Pi 3 or 4, I think. I'm not entirely sure, but it is a selectable RAM one, so I went for 4, sort of the middle of the road type of job.
Very good.
And you can probably guess, of course, it's still in the box. Haven't touched it. Not a thing. I've actually, well, I have. I opened the box to take the charger out because it was the same connector as my phone to charge my phone. But what would you recommend to start off with?
It's a tough one. It really depends on what you're interested in. I wouldn't jump straight into the deep end of setting up a data mode, but if you wanted to work on the input and output side of it, I would just start off by linking up a few LEDs and a few switches, and the fact that you can wire the switches so that they're acting as a trigger rather than a physical electrical connection, and you can read them inputs into the Raspberry Pi and then switch on and off LEDs, because if you're going into the programming side of things, or if you want to set up homebrew projects, sensing inputs and giving outputs is probably the base of all homebrew stuff that you can do with a Raspberry Pi.
Nathan, also the Raspberry Pi W is very good for wee hotspots.
Yes.
Wish they would make the friggin' pins a bit bigger because my eyesight's not getting any better.
Yeah, they can be a wee bit tricky to solder too, but
oh, nightmare.
Yeah.
Even with the magnifying glass, it's getting bloody worse.
Yeah. Another thing that the zeros are great for is if you want to set up like a home surveillance or some sort of camera, you can just put the camera in and tuck it away almost anywhere. I think I've even seen people using them as parking cameras on their cars, for example.
That's interesting.
Little screens hooked up, yeah.
I have the 0W, but it's in the box, like maybe other Raspberry Pi stuff.
That is a sin, Philip. That is a sin.
Well, I had the earlier Pis, and I give one of them away as a prize at one of the conventions we done years ago. Because I bought it and never used it, and then I give a young lad that come along to the radio club one night one too. I bought it, but I'm not getting rid of this W. I might buy one of the latest ones because they are powerful pieces of kit.
Yeah, without a doubt.
But I'll have to use it.
I'll be following up on you now, Philip.
I might follow up on you with that about the surveillance thing actually for the W, because a night of a wee project might need that. Would come in handy actually.
No problem.
Keep an eye on the old Muller when I'm not in the house.
Fair enough.
Terry, G3VFC, good evening, and thanks so much, Nathan. You mentioned about the camera. and the upmarket one was it 50 quid or something.
Yeah.
But you could put your own lens on. What is the mount of the lens? Is it some standard commercial consumer grade thing, or is it a good old-fashioned C mount?
As far as I know, the lenses that go in are some sort of standard. They're not proprietary or anything like that. But as for a mount for the camera, you'll probably have to either buy or 3D print some sort of case that you could screw onto threaded connector. I'm not quite sure what diameter or pitch it is, but there's plenty of cases out there. I think the Raspberry Pi Foundation actually sells them on their website. You can you can purchase the case and put the camera inside it, and it still leaves the lenses accessible if you wanted to change them out.
Thank you.
No problem.
Nathan, what's the maximum size of an SD card that can go on the board of the Raspberry Pi?
I'm not sure what the maximum limit is in terms of what the specs are, but I've tried it with up to 64 gigabytes. I don't see why there would be any reason why it wouldn't work with 128, to be honest. Because whenever you configure the SD card, you actually expand the partitions, so it occupies the whole space rather than just one small snippet of the SD card. So theoretically, it could work with as big an SD card, but there might be some sort of limitation there that maybe the technical people over at the Raspberry Pi Foundation have set. But like I said, I've used it for anything up to 64 gigabytes and it's worked just fine. So,
Yeah, thank you. Thank you very
much. Nathan, Ian here, GI0AZB. Excellent presentation. Well done. Really, really interesting. You've obviously added quite a bit onto it since the last time that I've seen it. So fantastic to get the up-to-date information. I was really, really interested in one of the slides that you showed your Yagi with the motors attached to it.
Yeah.
Yeah. Are those proprietary motors, or did you source them separately, Nathan? Could you give just a wee bit of information?
Them motors, one of them was a stepper motor and the other was a servo. Now the stepper can rotate 360 degrees as many times as you want, whereas the servo can only rotate about 180, 190 degrees. But the kit that I showed at the back end of the presentation, they came in that, and they were more than strong enough to flip that whole Yagi, vertical polarization, horizontal, and rotate it as well.
Excellent. Yeah. Have you got a link for those kits, or do you just simply Google Pi?
I would just Google or eBay even. That's where I got mine. If you want, Ian, I can send you the link to the actual one that I purchased.
Yeah.
But it came with an Arduino as well, so you might have even more tinkering on your hands if I sent you that link. But again, the kits are all out there. There's different contents in each one. That I picked up, I think it was £19, and I think whenever I priced everything individually, it was going to cost upwards of £40. So it's a great way of getting high quality stuff for cheap.
Are you sure you haven't a far out uncle that lives in Ballymena or somewhere?
Far out uncle? Not sure about that.
Yeah, a real bargain. Thank you very much, Nathan. Say well.
Right.
Excellent.
No,
I think Ian's trying to say us Ballymena folk are a bit tight, I don't know. The way I spend money, I don't know about that.
Nathan, your rotator's like a baby version of this.
It's definitely a baby version of that, yeah.
Yeah, I seen this at the convention, the RSGB camp. Now that antenna, the dipole's folded over in it. At the RSGB convention last year, it was developed by so that goes on the like a speaker stand. Antenna goes on here and it tilts and it rotates.
Very good.
Dean Bryce, the treasurer of the RAIBC, developed it, but I think he uses something similar to the wee servo motors. It's all inside here. Thanks to a wee app on your phone or your
Very good.
app or whatever. Have yet to use it, but the plan is to go portable and play satellite sometime, you know.
Very good,
It's
yeah.
actually quite a light device, and it's all
Is that right?
I don't know if it's 3D printed. It is 3D printed because it's still a bit rough here, but I think this was, here's a bit of waste pipe or something like that there, and it's just 3D printed or machined the rest of it and put everything inside it. But a good toy. I think George and whatnot would like one too, but we might, when Ulster gets going again, we might take it down someday and play with it.
Philip.
Yes, it's an ANZ rotator for satellites.
Philip, the Davy here.
Yes.
Did you not use that at the club one night?
I don't think I did I?
Did you not bring that down to the Mid-Ulster one time?
It was down on the Saturday after the
After the
rally up at Lisburn.
Ah, yes.
Yeah, but I don't think we just set it up. We did play with it. He did hook up.
You went outside and took one of my poles.
That's right. We did set it up, Davey. You're right. See,
you put it into the car.
My memory's that bad. We did, but I mean, we'll get it set up sometime and play with it properly. Dean come along with the president to the Lagan Valley Rally and just give us a wee demo of it after. That's right.
You can bring the pole back when you're finished with it.
I didn't steal your pole.
Not bring it.
Not guilty.
Really?
Hello, Nathan.
Yes.
Just a wee thing here. You were saying about 12-volt wiper motors there. I'm in the motor trade myself here, and the name's Eric. Eric was going to give it there. It's a GI0MSI. The wee 12-volt motors are very powerful. You know, they can drive a lot. I used to have a 2.5-inch reflector telescope using a 12-volt motor for the drive on it. But you can gear them up, and you can make a great drive off them. You know. But I was just wondering there, do you see those surveillance cameras? Can those be remotely controlled, or?
Yeah, if
you're way ahead of me here. You know what I mean. I'd be very interested in that type of stuff. You know, some of the sidelines I do have there. You know, but I was just wondering there, just what type of remote camera you could operate. You know, like from a distance. You know, put the camera up and then switch it on and off, or is that possible?
If you were mounting the camera somewhere where it had access to the internet, for example, you could stream that onto a web server, which could be hosted on the Raspberry Pi 2, and you could access that then from anywhere in the world, essentially, as long as you have an internet connection and can get onto that website. You could feed multiple cameras into that one website as well, and you can remotely then access it from your phone. If you wanted to be really fancy, you could set up an app. But what I would say is that there is a great article in that Raspberry Pi Explained book that I mentioned on setting up surveillance cameras, step by step on how to do it, the benefits, the drawbacks, things like that. But it's definitely possible. Again, it would be ideal with the Pi 0W because you can tuck it away anywhere. You can, if you wanted to keep it sort of hidden, you could keep it hidden behind a beam, for example, if it was in a shed or something along those lines.
Yeah. But I was thinking there, you see, we're doing a wee project here at the minute, not far from where I am here, and we have ground that we're putting equipment onto. And I was just thinking there, we have a place we could put, say, like a 12-volt battery or something like that there, and we could hide it. Even if we couldn't retrieve the information off it directly, maybe we could retrieve information off it later, as in a recording sort of a system.
Yeah.
Is that possible, or would it have to be directly fed?
No.
To, say,
you can. You can have
directly fed to a camera. Directly fed to a phone or some sort of a recorder that could be, say, set up somewhere else, that it could be receiving the signal from that. Do you understand me? So in other words, it would be a remote camera system.
Yeah.
What I'm trying to get across there.
I think if you want to record it and not necessarily access it there and then, without a doubt, you can just have it save the footage. Even if it took a few photos every 2 seconds, it would cut down the file size a lot. And then just whenever you're starting up your Raspberry Pi, just load it with a large SD card, something like a 64 gigabytes, and it can store that footage, probably for, I would say, a week maybe. It just depends on how often you want it to take a photo or how long you want the video to go on for. But it does have the ability of storing it, yeah.
Yeah, you could also have it motion censored, couldn't you? That it would only detect motion.
Without a doubt. I'm just seeing I have a little motion sensor here.
Yeah.
It's just a matter of hooking up these 3 wires.
Yeah.
One of them's power, one of them's ground essentially, and the other is signal. So whenever it detects anything, it can trigger the camera. There's a great article on the Raspberry Pi's website on how to do that. Then on the back end of it here, I don't know if you can just make that out, there's 2 potentiometers, so you can adjust the sensitivity of it as well. So if you want birds setting it off, for example, it has to be something more substantial, like a human being.
Like a person type thing.
Exactly.
Yeah, very interesting. You're talking about SD cards. Could you use the likes of this little thing here? I want to see, where's my camera here? The wee miniature.
That's what it takes now. It used to take the larger ones, which was a bit of a pain, but now just standard
here.
Yeah, it used to take
this stops into the bottom of it here.
That's right.
Yeah.
But now all it takes is the micro or the mini.
The microchip,
yeah. That's
very interesting. Very interesting. Well done, Nathan. Very interesting. I tell you, you're way ahead of me. I would like to be where you are now.
Oh no!
I have probably too many grey cells now, or whatever,
Not at all. Not at all.
Thanks for that chat there.
Thank you.
I'll let somebody else take it over there from me.
Well,
Nathan,
thanks again, Nathan, for delivering a presentation. Definitely, it is one of those things that, one of those presentations that you come away with a bit more enthused than before, especially when it comes into delving into tinkering, as you called it, in and around the shack, and there's so many different things you can do. So, Nathan, fantastic. Thank you very much. And feel free, obviously, everyone hang about there. If there's more questions for people to ask, feel free there. Yeah. I'm sure Nathan hasn't felt too bad there, because he's coped very well with all the questions that's been thrown at him so far. And he said and I'm sure, as he said, that he was no expert, but I would say he's definitely more of an expert in the Raspberry Pi field than what I would be. So, Nathan, from us here, thank you very much, and great to have you along.
He's more of an expert than it was all put together, Dave. I don't know if Dave told you, but there is a plan later on. I don't know if the date's set for Mike Richards to do a talk. Maybe if you could join us that night, you and Mike.
Yeah, I'd love to, yeah.
He'd be really happy to see that you dropped his name a few times tonight, checking out of his cards.